Hello students, good morning to everybody. How are you? In your last video we discussed about some problems relating to exponents. Today we will do more questions relating to exponents. Exponents is a very easy chapter. Now let us come to solve problems. Question number 1 is prove that one upon 1 plus x to the power b minus a plus x to the power c minus a plus 1 by 1 plus x to the power a minus b plus x to the power c minus b plus 1 upon 1 plus x to the power b minus c plus x to the power a minus c is equal to 1. This is the problem. Now we will prove this problem. Again I am reading this problem. 1 by 1 plus x to the power b minus a plus x to the power c minus a 1 plus x to the power 1 by 1 plus x to the power a minus b plus x to the power c minus b plus 1 by 1 plus x to the power b minus c plus x to the power a minus c. This is important problems. I discussed only important problems. So take is equal to 1. Then LHS side. LHS side is equal to. If we write LHS is equal to, so this is our first step. We will do the next step. LHS is equal to, I told you that you should do the immediate step, which you show the immediate step. First we starting the immediate step, that is the step 1. What is the immediate step? 1 upon 1 plus. Now look this LHS side. What you will judge? What will be? Now nothing we can judge, only we judge x to the power b minus a. When indices are subtracted, it must be division. When index are added, so it must be multiplication. So here we implement the formula x to the power m by x to the power n is equal to x to the power m minus n, not this x to the power m minus n. From right side to left side, I always told that you should remember the formula after understanding from both sides. Left, whenever left side is your question, right side will be the answer. Right side, when right side will be the question, left side will be the answer. So x to the power b minus a means x to the power b upon x to the power a plus x to the power c minus a means x to the power c upon x to the power a plus likewise second term 1 upon 1 plus x to the power a minus b means x to the power a upon x to the power b plus x to the power c upon x to the power b plus 1 upon 1 plus x to the power b minus c is equal to x to the power b upon x to the power c plus x to the power a upon x to the power c. That is our immediate step according to laws of indices. Then next what we will do now, numerator, total is denominator, denominator also a fraction. First solve the denominator fraction. 1 plus x to the power b by x to the power a plus x to the power c by x to the power a. So this is 1 plus LCM 1 upon, then take LCM x to the power a is the LCM. So x to the power a by 1 into 1, that is x to the power a plus x to the power b plus x to the power c plus 1 upon LCM here x to the power b, then here x to the power b plus x to the power a plus x to the power c. Likewise 1 upon LCM x to the power c, x to the power c plus x to the power b plus x to the power a, that is equal to, now this is 1 and this is the fraction. This is a new fraction. Some students do wrong in this procedure. So here we first judge what is our first fraction. This is numerator, this is denominator. Next denominator changed into another fraction. So this is the numerator, this is the denominator. 1 by this. So multiply this fraction by reciprocal, turn into reciprocal. It will be x to the power a upon x to the power a plus x to the power b plus x to the power c plus x to the power b upon x to the power a plus x to the power b plus x to the power c plus x to the power c upon x to the power a plus x to the power b plus x to the power c, that is equal to, now general addition things, this is a fraction, this is a fraction, the numerator denominator are same, so we take denominator as a x to the power a plus x to the power b plus x to the power c, in numerator x to the power a plus x to the power b plus x to the power c. So this cut off, that is equal to 1. Prove. Very easy, just no, not much formula is implemented here, only one formula we can do it. X to the power m minus n is equal to x to the power m by x to the power n. Then we do the algebraic formula, addition, subtraction, then result is 1. So the RHS side which is 1. Now take a screenshot, we will do the next problem. Question number 2. If a to the power x is equal to b to the power y is equal to c to the power z and bc square b square is equal to ac, prove that y is equal to 2xz upon x plus z. Y is equal to 2xz upon x plus z. This was the question. Whatever it may be, but it looks like a complex problem, but it is not complex, it is so easy problem. If we now our given point solution, now look what are our points. x to the power a to the power x is equal to b to the power y is equal to c to the power z. Otherwise, b square is equal to ac. So here b square is equal to ac. Here b square means b is the base, 2 is the index. But ac is the another factor, a into c, which in the previous statement a to the power x is equal to b to the power y, b to the power y is equal to c to the power z, c to the power z is equal to a to the power x. All three expressions are equal. This equal to this, this equal to this. Now we will take a as the subject, express a in b form, express c as in b form. So first take a as the subject, then c as the subject. Object will be only one object, that is b, because the left side is b square. So a to the power x, b to the power y, c to the power z. In these three expression, we take a as the subject, then c as the subject. In both cases b will be the object, subject of the formula. Let a to the power x, a to the power x is equal to b to the power y. So implies that what is a? If square omitted from the left side, in the right side we will do square root. Square root means, suppose here is a example, x square is equal to y, implies that x is equal to square root of y. What is the meaning of a square root of y? That is equal to y to the power 1 upon 2. We don't write the square root, but here a to the power x is equal to b to the power y. If you omit x, so it will be x root of b to the power y, or 1 by this power goes to the denominator of next power. A is equal to b to the power y upon x. This is equation 1. Then c and b, compare c and b. So here is a is the subject, then another subject will be c. C to the power z is equal to b to the power y, implies that c is equal to b to the power y upon z. It is equation 2. So now we turn c, a as a subject, b as a object, and here c is the subject, b as object. You already know that what is subject, what is object, what is complement, but the English grammar is also applied in the geometrical or mathematical expression. In your topic, one topic, subject of the formula. This is the subject of the formula. Now take this thing. So b square is equal to ac, implies that b square is equal to a, means b to the power y upon x into b to the power y upon z. That is implies that. So here b and b are same base, they are multiplied, so index will be added. So b square is equal to b to the power y plus y upon x plus y upon z. That is implies that b square is equal to, so base cut off, implies that 2 is equal to y, here common, 1 upon x plus 1 upon z. Now take LCM. 2 is equal to y into LCM xz. So it will be x plus z So y into this is equal to 2. So y is equal to 2 into xz upon x plus z, that is equal to 2 xz upon x plus z proved. This is just algebraic simplification. So I always tell simplification, expansion is very important. Wherever, anywhere it will be implemented. So take a screenshot. Then we will do another problem. Question 3. If m is not equal to n, m plus n to the power minus 1 into m to the power minus 1 plus n to the power minus 1 is equal to m to the power x into n to the power y, so that x plus y plus 2 is equal to 0. Then this much is a question. If m is not equal to n, m plus n to the power minus 1, m to the power minus 1 plus n to the power minus 1 is equal to m to the power x and into n to the power y, then prove that x plus y plus 2 is equal to 0. Solution. Now taken the given point, solution is equal to means this is the first step. So we know x to the power minus 1 is equal to 1 by x to the power 1 or 1 by x. The minus power changed into plus power. So first omit the minus power, minus index. So m plus n to the power minus 1 means 1 upon m plus n. Then m to the power minus 1 means 1 upon m plus 1 upon n, that is equal to m to the power x into n to the power y, implies that 1 upon m plus n is equal to 1 by m plus 1 by n is equal to m to the power x into n to the power y. Now minus index changed into plus index or negative index changed into positive index. That's why the problem will be simplest. So now 1 upon m plus n here into take LCM mn, so it will be m plus n, that is equal to m to the power x into n to the power y, implies that m plus n cut off, m plus n and m plus n cut off. So m into or 1 upon mn is equal to m to the power x into n to the power y, implies that m into m to the power x, n into n to the power x. So m to the power x into m into n to the power y into n, that is equal to 1. that is equal to 1. Now m to the power x plus 1 into n to the power y plus 1 is equal to 1. Sorry, m to the power x plus 1 n to the power y plus 1 is equal to 1. Instead of 1, in the place of 1, we can write anything else, any non-zero number which power is 1, which power is 0, the result will be 1. So here we will take m to the power 0 into n to the power 0. Is it wrong? Because anything else to the power 0 is equal to 1. In 1, we can write m to the power 0 into n to the power 0. Now m factor equal to m factor, n factor equal to n factor. M to the power x plus 1 is equal to m to the power 0, cut off. So x is equal to minus 1 and n to the power y plus 1 is equal to n to the power 0, implies that n cut off, y plus 1 is equal to 0, so y is equal to minus 1. Now take LHS side. LHS is equal to x plus y plus 2, x plus y plus 2, that is equal to minus 1 plus 2, that is equal to 0, proved. This is a very, very important problem. Now look this problem. M plus n to the power minus 1, m to the power minus 1, n to the power minus 1. In physics, you tell m plus n inverse whole into m inverse plus n inverse. The unit of velocity, force, that is inverse. When inverse change, it will be the denominator. Simply it will be s inverse means 1 by s, m inverse 1 by n. So likewise, and this will be here 1 by mn is equal to m to the power x into n to the power y, then m to the power x, then this denominator it is multiplied to the another side. Now the result will be m to the power, in the place of 1 we write m to the power 0 into n to the power 0. So m equal to m factor equal to m factor, this exponential factor is equal to this exponential factor. That's why the x plus y plus 2 is equal to 0, which is proved. So the exponent topic here is over. I hope there is no problem in your exponent topic. Hope you will do better in this chapter. And for today, this much. Very good. Thanks. Goodbye.